Welcome to the webinar on building non-eye tracking experiments in Experiment Builder. Today it should be a pretty brief webinar. It's not too hard to build non-eye tracking experiments in Experiment Builder, but it's important to make sure to do a few things correctly. So I just wanted to cover all of that stuff in a quick webinar. Okay, so in terms of today's webinar, first we'll just do a brief overview of what Experiment Builder is and how it works. Mostly I'll just point you to an Experiment Builder video tutorial series that you can check out to get some kind of deeper background on how Experiment Builder works. Then we'll just quickly talk about the considerations that you need to keep in mind when you're building non-eye tracking experiments. In general, non-eye tracking experiments are very similar to eye tracking experiments, but obviously, like, you're not going to be able to use the eye-link specific nodes in a non-eye tracking experiment. That doesn't really make any sense. So we'll talk about that stuff. But most importantly, you need to make sure to remember in a non-eye tracking experiment to use what's called a results file, which will create a tab delimited text file that will allow you to log your condition, like independent variables, data source columns, as well as logging any behavioral data variables that might be collected. So like reaction times and accuracies and which key did they press, that kind of information. You want to have a record of that stuff. And then we'll just, so to talk about those considerations, I'll just go through a non-eye tracking experiment that I've already set up, and it's really just a modification of the experiment that's created in the video tutorial series. And then at the end of this webinar, I'll show you how I turned the picture response eye tracking example into that non-eye tracking example. So in case you're trying to just adapt an eye tracking example to become a non-eye tracking example, I'll quickly go through how to do that. Okay, so let me mention before we jump into the kind of hands-on stuff, this PowerPoint, which has more slides than we've gone through so far, it will be posted at the same page where the webinar video will be posted. So you can, if you're in a hurry or don't want to watch the video, you can just check out that PowerPoint. It kind of covers these topics that we're going to cover too. So you can use that for reference, and the examples that we're going to talk about are going to be posted there as well. Okay, so let me exit out of this, and let's just jump into the non-eye tracking example. So this example is called non-eye tracking picture response. It looks like maybe I made a change, so I'm gonna save that. Non-eye tracking picture response, and it's just a modification of the picture response example that is covered here. I mentioned I would talk briefly about how Experiment Builder works. So let me just show, let me show you here. Experiment Builder is a graphical user interface based experiment creation software. That's kind of a mouthful. So it's a software package that you can use to create experiments for social sciences. And it's got a graphical user interface that makes it pretty easy to use. It's pretty powerful and flexible, meaning you can create a lot of different types of experiments with it. To create the experiments, you drag and drop these nodes. We call these nodes up here. You drag and drop them into this graph editor, and there are several different node types here you can select from. You connect the nodes to one another, and then when you run the experiment, it will really just go through the nodes in the order that they're connected. So that's the gist of how Experiment Builder works. If you want some deeper background on it, you can go to sr-support.com. You can make a free account there to check out our support forums. And then you can go to video tutorials and then check out this Experiment Builder video tutorial series. And it's like about an hour long or so. And you can download the example that it discusses here. And this is a modification of that example. So basically, when you run this experiment, on each trial, it presents either a color picture or a black and white picture, and the participant should press one of two keys, one key to indicate it's a color picture and another key to indicate it's a black and white picture, and then it gives some feedback to tell the participant whether their answer is correct or incorrect, and then the trial ends. And when the trial ends, it logs which key they pressed, what their reaction time was, and their accuracy, as well as the condition information to a tab delimited text file that's called a results file. Okay, so if you compare this experiment to the eye tracking experiment discussed in this video tutorial series, you'll see it's very similar. So basically we have a sequence here called block that handles the looping through our different blocks of the experiment. You can see we have 3 blocks here. And if you go in there by double clicking on it, you can see at the beginning of each experiment, of each block, it shows some instructions. It just shows this. It's kind of a simple design. Then it waits for a key press, and then it starts another sequence, which is like a looping structure. So we got a sequence inside of a sequence, and this one is called trial. And you can see it has a data source associated with it over here, but if I select it, you can see its properties over here. And if you click on that, you can see these are the different columns that contain the information that will change from one trial to the next. And so you can see we have just like a unique identifier. We have a column indicating the name of the image file to use on each trial. We have a column indicating the practice status, whether it's a practice trial or an experimental trial. Then we have a column indicating which key the participant should press if they're responding correctly on the trial, so it's correct response. Then we have some block and list columns that help us control the randomization kind of constraints that are applied, randomization like that's applied to the order of the trials. And then we just have a column called image type, which codes the condition, whether this is a color image or a black and white image. Okay, so that's this trial sequence here, and it's going to loop through all the different trials of the experiment. And on each trial, we prepare the trial. So this is just like an eye tracking experiment. We have a prepare sequence, which looks to the upcoming trial and loads up any images, sound file. In this case, we're not using sounds, but if we were, sounds, videos, basically loads up any stimuli that are going to be presented into the computer's memory. And it also kind of reinitializes like the actions and triggers generally. So it kind of resets everything, gets everything ready for the upcoming trial. Then we have, just like in an eye tracking experiment, all the actual trial events are housed in another subsequence that doesn't do any looping. So you can see it just has an iteration count of 1, meaning it's not going to like repeat. It's just gonna, on each trial, we're gonna enter that sequence, do all the events in there, and then exit the sequence. And the reason we're using that here is just so we can put the computer into what's called a real-time mode to just make sure that timing is as optimal as possible. So the structure generally is like an eye tracking experiment. And if you look inside the trial event structure, you'll see it's basically exactly the same, with the exception of, in this case, we added a results file. Add to results file node at the end of the trial, and we have a results file node here. So what this does is it will, what the combination of this node and this add to results file node does is it creates this node called results file creates a tab delimited text file that will be saved in the participant's results folder at the end of the run. And that tab delimited text file will contain lots of columns, and you can select the results file node, and this comes from the other category of nodes here. So it's just drag and drop this into the experimental flow, and it doesn't connect to any other nodes. It's just creating a results file. But anyways, you drag and drop this, and then you can set up the columns that will be written in this file by editing the columns property. So you can click on that, and a little dialog appears that allows you to select which variables. By variables, these are the columns that will be included in the output file. And by default, it includes all of the possible available variables. And by variables, what I mean is these data source columns will become columns in the results file, and these variable nodes can and by default will become columns in the results file. So if we check out the columns property again, you can see here are all our data source columns here. It also includes by default the subject or the participant's session name and trial number and whether the trial was recycled. But you have the data source columns here. And then down below, you can see we have these variable nodes, which will store our behavioral data. And so this is, you set up the columns that will be included in that tab delimited text file here by editing the columns property. And then at the end of the trial, you use this add to results file node, which is in the actions section of nodes, to write a row to the output file. So basically, since we're writing one row at the end of each trial, in our tab delimited text file, we're going to have a file where the first row will be the column names, and then the additional rows will each represent a different trial of the experiment, and they will contain the trial data through the variables that we included. Okay, so the reason why we're including a results file here is because in a non-eye tracking experiment, we don't have an eye tracking data file. So when we're doing an eye tracking or an iLink experiment in Experiment Builder, we're always going to be creating an EDF file that will be written by the host PC, and at the end of the session will be transferred over to the display PC so that we have all the eye tracking data. And in an eye tracking experiment, all those data source columns and variable nodes are just automatically written to the EDF file at the end of each trial when you exit out of the trial recording sequence. But since we're not doing an iLink experiment, since this is a non-eye tracking experiment, we don't have any EDF file. There's no host PC, and so there's no EDF file. So what we're doing here is just making sure that we're writing our trial information to a tab delimited text file so that we can have that for data analysis purposes. So really, you just want to make sure that you have this results file and that you have add to results file at the end of each trial. And then other than that, it's basically the same. Another thing I want to point out, though, is that even though this is a non-eye tracking experiment, it's really important, or not, I wouldn't say necessarily really important, but it's a good idea to fill out the message property of all the actions and triggers in your trial event sequence. So you can see for our display image, we have a message listed there, and for our keyboard response, we have a message listed there, blank screen. At the end of the trial, we have a message listed there. This, when you run a non-eye tracking experiment, it will by default, it will create a messages.txt file, which is just going to be a text file that's going to write these messages in a timestamped manner to that file. So if you ever wanted to check the timing of your different trial events, then as long as you've filled out these messages here, then you'll have a messages.txt file that will contain timing information for these different experimental events. So that's a good idea to do as well. Okay, so really that's the gist of how to create a non-eye tracking experiment. You want to set up your looping structure through the trial sequence, make sure you use a prepare sequence, and then have a trial event sequence that will handle the trial events and that doesn't do any looping. And then you want to make sure that you're setting up a results file that's going to write your trial information. So let's quickly run through this so we can see how it works and see what the data looks like. So I'll just, I'm going to do a test run here, but before I do that, I'm going to turn on a webcam that I have pointed at the monitor, and I'm just doing this because I've discovered that this webinar software, when you start an experiment builder project, it kills the screen recording, and so I'm just going to turn on the webcam so that we can see what's happening on the screen. So turning on the webcam, and now let me hide this. Let me do a test run, and that's just a warning that's saying we're doing a test run, and so we shouldn't do that for real data collection. For real data collection, we should always deploy the experiment with this button and then run the deployed project. You can learn more about that from our tutorials and manual and stuff. Okay, but anyways, we're doing a test run here. I'll just use the session name test, And this will be the name of the folder that will be saved in our results folder of the experiment. And in this case, we have a counterbalance design. So it's asking us to choose which value of the list column in our data source. And so I'm going to choose 1. Okay. And we got some instructions. Welcome to the experiment. Press a key. Then we get the block instructions. Press Z for color images and / for black and white images, and then press a key to begin the block. And if I remember correctly, we have basically a practice block followed by 2 experimental blocks. So first we'll do the practice block, and we got a color image there. So I'll press Z, and we get a feedback correct. Okay, we got a black and white. This time I'll answer Z just to show you what happens if we're incorrect. So I'll say Z, incorrect, okay. Now we're at the first experimental block, so we repeat these block instructions. We got a color, we have a black and white, so I'll press /, and that's correct. Okay, color, I'll press Z. Then let's do another incorrect, so I'll press /, that's incorrect. Okay, then we have black and white, I'll press /, and then another experimental block, press /, Z. Okay, so that's the end of our little test run. Let me turn the webcam off for a second. Now let's go back to our project folder, and that's this non-eye tracking picture response. And let's go into the results subfolder. You can see there's our test file, our test subfolder, which was created because that's the name we specified at the beginning of the run. Then we have our results file, tab delimited text file. And so I'm just going to right click and open this with Excel, so it's kind of easy to read. And let's expand the column name. So you can see here, these are our data source columns, and our data source columns here and our variable nodes here at the end. And so you can see we have all our kind of trial information here, and then we have our dependent variable information that we collected here. So that's how we can use this to analyze the data. So we get reaction time, accuracy, and key pressed. I realized I forgot to point out one kind of important thing. So to log the information about variables in an experiment builder project, you first add these variables by adding these nodes here to the workflow. And then after a response is made, you can set the values of these variables using update attribute actions. And if you want some more information on how to do this, you can, as I mentioned, check out this experiment builder video tutorial series. And there's a video here called behavioral data logging. So you can check that out for more details on that. But that's basically how the values of these variables get set. And then we're writing them to the results file we can see here. Now let's check out one final thing. Remember I said that those messages of the different nodes, these messages here, will be written to a messages.txt file. So I'm just going to open this with a text editor, Notepad++. And you can see we have timestamps here, and we have all our different experimental messages here. Let me point out here, sometimes you'll see these messages begin with numbers. Experiment Builder basically writes the messages ahead of the events sometimes, and it does that to kind of preserve resources, but it basically checks the time of the upcoming experimental event against the current time, and that number represents that offset difference. And so if you want to find the time of that actual experimental event, you need to subtract this number from the timestamp. And so in this case, we could say that display blank, instead of occurring at time 62944, would have occurred at 62957, because we subtract -13. So 62957. So just keep that in mind in case you're trying to look at the timing. Okay, so that is how you can do a non-eye tracking experiment. So let's do one final thing in this webinar. Let's talk about how you can turn an eye tracking experiment into a non-eye tracking experiment. It's pretty easy. And this is literally this project here that's in our experiment builder video tutorial series. And so I'm just going to show how to turn that into a non-eye tracking experiment. Okay, first thing to do is go to edit, preferences, and this brings up the general experiment preferences, and you can go to this experiment section here, and then see how iLink experiment is checked. We want to uncheck that, and it says you're changing from an iLink to a non-iLink, and this will delete any iLink associated nodes, and that's fine. We want to delete them. Actually, before I do that, let me just show you what we mean by that. So if we go back to the beginning, we have a camera setup, which is where we do the eye tracker calibration. At the beginning of a trial, we have a drift check. So those are iLink nodes. And if our trial event structure had some of these gaze-based triggers here, those would be deleted as well. Okay, so let's go back. Edit preferences, and then let's uncheck iLink experiment, and we'll just say, okay, that's fine, let's delete those nodes. And you can see they actually disappeared from the possible nodes that you could add, so we don't have those gaze-based nodes anymore. And when we go back to the beginning of the experiment, our camera setup action is deleted, and so we need to fix those connections. That's the next thing to do. And if we go inside our trial sequence here, then we can see the drift check is gone, so we need to fix that connection. And then finally, since we don't have a host PC or eye tracker anymore, we're not going to have an EDF file saved, so I need to go into the other category and add a results file node, and then make sure it has all the columns selected that we want to be written to that tab delimited text file. And then we want to make sure to actually add a row at the end of the trial. So I'm going to click add to results. I'm going to add an add to results file action. It looks kind of like this, but it has a little plus there. And I'm going to add that at the very end of the trial event, and then we can clean up the kind of organization using this button here, arrange layout. Just so basically we have a results file. We're adding a row to that results file at the end of the trial, and we fixed any connections that were broken when we changed to a non-eye tracking experiment. And at that point, you have officially changed the eye tracking experiment or iLink experiment to a non-iLink experiment, and you should be basically ready to go. So you could do a test run, make sure it works, then deploy the project and start your data collection. Okay, so that's everything that I wanted to cover today. As usual, if you have any questions or, thoughts, anything like that, don't hesitate to get in touch. You can send us an email to support@sr-research.com. You can post on our support forums. You can give us a call, basically whatever you want or prefer to do to get in touch. Don't hesitate to do so, and we'll be happy to help you with your specific questions. So good luck with your experiments out there, and stay safe and healthy.